Hi, everyone, and a very, very happy Tuesday. My camera will turn on in a second, I'm sure. And welcome to our ARM Tech Talks. This is the place for the latest and greatest in trends, technologies, and best practices from ARM and our ecosystem. And it's great to have you wherever you're joining us from. I'm just going to switch cameras, tech problems as usual. There we go. I'm back. There we go. You can see me now, as well as hear me. And welcome to our ARM Tech Talk. So it's great to have you wherever you're joining us from. If it's your morning, your afternoon, your evening, if you're joining us in the car, if you're grabbing a coffee, wherever you're joining us from, it's great to have you. Today, I'm thrilled, really, really excited to have GitHub being on our ARM Tech Talks today. It's great to have them joining us. They're going to talk about something really exciting, about how you can use GitHub Actions, ARM virtual hardware, join together the ARM development tools together with GitHub, and how they just work so brilliantly. So I'm really excited for them to show you that, talk through it, and show you a quick demo later on in today's talk. Before we do, I've just got a couple of little things I want to run through. If you've joined one of our tech talks before, you know the drill with this, but just want to go through a couple of little items just to recap how you can get involved with the conversation today. You can tweet us using the hashtag ARM Tech Talks. You can view all of our tech talks on demand, including this one. As soon as we finished, it will be available immediately on the ARM YouTube channel, which is great. So you can view this one together with all 50 plus prior talks on the ARM YouTube channel there. So do make sure you check those out. We've had everything from Matter through to AI, it's been an incredible series of talks this, so do check those out. And if you like what you see today and want to catch an upcoming tech talk, then head to arm.com/tech talks for all of those. As I say, we do these every week. All the recordings are available immediately. All the slides are available immediately afterwards. We do these every week at 4 o'clock GMT, 8 a.m. Pacific time. So make sure if you like what you see today, you head over to arm.com/tech talks to find out what's coming up. You can have a little sneak peek now if we head to the next slide at our upcoming schedule. So we've got a bunch of talks coming up, really focused around some exciting partners and demos that we're showing at Embedded World. So on March the 14th, there won't be a tech talk because we've got Embedded World. So if you're there, do come and join us. And I'll tell you a bit more about that after today's talk. So today we're going to be hearing from GitHub, which I'm really looking forward to. And then we've got a bunch of talks from 56K Cloud, Eurotech, and Keekso, talking about a variety of different exciting initiatives and projects and ways you can get involved with ARM and these companies. And you'll be able to see a little sneak peek of what they're working on for Embedded World. And then, of course, if you're going to Embedded World, then, of course, you can meet these guys and girls in person. Well, let's talk about today's tech talk, right? Let's get to talk about GitHub. We're going to hear from GitHub today and how you can use all of their exciting tools together with ARM virtual hardware and ARM development tools. So I'm really excited to hear from them. If you've got any questions throughout today's talk, use the Zoom Q&A box. It's down at the bottom below. Do ask them there, and I'll get to those at the end. So Clay, Max, it's great to have you joining us today. I'm really thrilled you can join us and give us today's tech talk. I'm going to let you introduce yourselves and then go through today's talk. So Clay, Max, I'll hand over to you, and I think, Clay, you're going to introduce yourself first.
Yeah, awesome. Thanks, Tobias. I appreciate it. Hey, I'm Clay Nelson. I run sales in the central U.S., and I work with our embedded and automotive community. Max?
Hi, I'm Max, and yeah, thank you for introducing us so nicely. I'm a senior solutions engineer. That means I work with the largest customers here in the German space and figure out with them what their technical needs are and how GitHub can really help solve them and bring them to a better future. Right.
Awesome. So, talk a little bit today about first sort of enabling software development in the cloud. We'll talk some about what cloud native software development workflows look like. And then we'll do a demo of the ARM virtual hardware in actions. Max will be driving that. Before I do, just real quickly, I want to take an opportunity. If you don't know who GitHub is, GitHub is really hyper focused on the developer experience. We really believe that by removing friction, we can unlock both individual and team performance, and that frees up bandwidth for innovation. And even though, like, I've been I think 8 years at GitHub. The company's been around since 2008. I think people still very frequently think of us as just a code repository or the home for cool stuff I go download to run hobby projects. But we're definitely a enterprise platform for accelerating software delivery, all sorts of development. And since we've been since 2008, which when we did start obviously as a code repository, we've added all sorts of functionality that goes across the entire life cycle. So from idea to deployment to integrating application security and secret scanning. There's a whole host of things that we're doing. So over 100 million users. That's pretty much the commercial part of the discussion. So because this is primarily a tech talk. But we do want to set some context and vision for why we're working with ARM and what we're here to learn and hopefully share with you and get some feedback from this audience. Max, you want to jump to the
Definitely
next slide? So one of the realities of modern life is the amount of change that we all deal with, and embedded development is, of course, facing its own set of changes from multiple forces here. And this is just this a little bit busy slide. I apologize, but want to kind of get across how these changes can be dealt with best practice or strategies, and how those things reinforce each other. So even though, let's start with maybe the one up here on the top, the thing that's probably driving a lot of us, and that's accelerating expectations from our customers. I used to think we had some degree of separation in technology markets just because I got my cell phone here, just because I had expectations for the pace at which stuff was delivered here. Didn't necessarily jump over to other products and services that I used every day in my life. And like you probably didn't know that you really wanted a thermostat that you could control wirelessly from your phone until you had it, and now I want everything wirelessly controlled. And at some point, people were manufacturing bicycles probably thought that they didn't need to build competency in software development. But as cost of sensors and wireless connectivity and compute drop, of course, we now got bicycles that's got smart locks, and you can rent one walking down the street. It's built-in GPS and fitness tracking, all sorts of things that are built into it. So that the expectations jump, and we have to have the adaptability as enterprise development teams in order to cope with that amount of change and rising expectations that come from all sorts of places. And I think we've seen, and there's a lot of research that shows that there's a renewed interest in adopting agile methods in the embedded space. And I think what thing we're talking about here today is this virtualization has enabled teams to begin development much earlier in the process, because we don't necessarily need to wait for the hardware target to be defined or even complete, and so we don't have to work as linear as we did. And so agile methods become much more approachable than I think they were in the past. And so some of the other forces acting on embedded developers, of course, is the rise of multi-core processors, sort of up here on the other side, and that's of course introduced lots of opportunities, but for what the products that you're developing can do, but the complexity of the architectures and the combination of sort of this broader set of teams that you have to work with increases the complexity. So there's complexity in the architecture and complexity in the coordination across the teams that you're now dependent on, and that increases project risk. So that one of the ways of dealing with that, of course, is increasing the frequency that we're doing debugging and testing, and that's in essence what the heart of this continuous delivery and integration bubble represents. There is that while it's possible to look at each one of these strategies in isolation, the multiplying effect on team productivity becomes, I think, much more apparent when you consider how they interact with each other, particularly in the cloud. So we can, get developer productivity gains as an individual by adopting some of these things, but when you start looking at these in the cloud, we can really talk about scaling them to the enterprise and even into entire ecosystems. Of course, breaking architecture down into smaller pieces, reusing components from open source or partners, even the owner enterprise, I think is possible only if you're automating and using CI/CD practices. So, I mean, we can't keep up with that pace of consumer expectations if you're not applying automation. And then this other sort of open source, I think, our community-driven development bubble there. As we see open source continue to flourish, a lot of teams are looking at these work patterns as ways to mimic inside of their own enterprise how open source teams who manage to develop some of the software that we build on top of don't necessarily have daily stand-ups, or they're working much more asynchronously, and so there's value to working in an open method. Next slide, maybe now talk some about how cloud-based workflows accelerate embedded development. We're again, primary purpose here is talk about continuous integration and delivery, but more broadly, I think the cloud offers the ability not just to free yourself from hardware constraints, but it also, I think, enables us to consume the work products of other teams with a lot less friction. And one of the other examples of that we're not going to really get into today, but I encourage you to look at is cloud-based IDEs like GitHub's code spaces. I think you can imagine that, well, we're already doing this in some places. You can imagine where this is going to go, but enabling developers to spin up a development environment without spending hours, trying to confirm that you got the right libraries in place, right configurations. And, if you're working on some new innovation or new project, and then you get the phone call from the project manager that you need to fix an issue, an urgent issue, an older version, the ability to just quickly go stand up that environment that's right next to the code and not have to spend, hours switching back and forth is extremely powerful. And then being able to share those environments, not just maybe, with your own team, but, abstracting that complexity away so that you can bring in new developers or accelerate the pace at which your customers are maybe even interacting with you and building on top of the work that you're doing. So with regards to, I think, applying continuous integration practices, I think one of the promising aspects of this partnership with ARM is our ability to enable horizontal scale of the compute in continuous integration, and without the constraints of the license, managing your own infrastructure. And Max is going to talk through this a little bit more in a few minutes, but that's where we're headed with this tech, is so that I need to fire up multiple targets and run these things in parallel, and I'm not constrained by the hardware that I either have connected to my machine or in our server farm. So those are just a couple of things I wanted to kind of set some context for. Max, thoughts on
Definitely. Something that I just thought was also when you mentioned the cloud-based code spaces IDEs, for example, something, it's completely counterintuitive in the first place to think of embedded development in the cloud, but I mean, here we are.
Yeah.
Here's what we're presenting today. And I think one of the main values behind this, being able to have this big exchange of configuration, this big exchange of computing power that you can tailor to what exactly you need in this certain moment, is that it gets all of the stuff out of the way that you as a developer don't really want to care about while you're writing a feature, right? You want to think about how you can optimize the algorithm. You want to think about how you can optimize the code, and you don't want to be stuck thinking about, oh, darn, which version of, which compiler did I install now, and how do I manage the different compiler versions? That's not the exciting stuff. The exciting stuff
Sure.
is the code, and that's sort of what we're trying to show you today, our approach, how we can make that a much faster and easier experience for you as developers to get your code tested at scale without having to care about all the surrounding stuff that usually makes embedded development a bit harder than, just traditional software development. And maybe I'll dive right in here. So
Sure.
of course, this is an approach where we're partnering very closely with ARM, and where we're using ARM virtual hardware as the foundation to simulate, to bring this embedded workflow into the cloud. And maybe to quickly reiterate what ARM virtual hardware actually is for everyone that has not heard of that yet. It's basically a simulation of an ARM chip, of a system on a chip, that you can actually, completely independent of the underlying hardware, run inside of a cloud infrastructure. So you don't really have to care about any physical chips, about plugging things into USB ports. You can just quickly spin up instances and get started with testing and executing your compiled programs on these chips that will behave exactly as they would on the real deal, right? But at the same time, you don't have to worry about buying the chips. You don't have to worry about getting them into the target state and maintaining them in the target state after each test run. You don't really have to wait for, and that's something we saw in the past few years, for global supply chains to supply you with a proper amount of chips if you're doing that at a certain scale, right? If you're a company and you're having, 400 developers that need to test your code every day, multiple times, the amount of effort that you would have to invest into just maintaining this hardware, to have huge halls full of computers with wires dangling out of them, little chips connected everywhere, making sure that not all of these chips fail all the time. That's something that we can, forego with this ARM virtual hardware approach, by just saying, look, let's take the ARM virtual hardware, put that inside of GitHub Actions, and just scale it up on the cloud, and forgo all of this pain, and of course also cost that's associated with that, right? So when I say we can forgo all of the dangling wires and all of the halls full of computers that that cost a lot of money, what does our workflow look like that we want to propose? So maybe, and that surely does not apply to everyone, but maybe you know the situation, right? Your workflows are they're associated with a high effort to run. So you might run your end-to-end workflows only once, twice, or 3 times a day for all of your teams. It takes many hours to run. And you don't really get immediate feedback about what you've created there. Now, our counter proposal to that is to just use the GitHub Actions runners that are ARM enabled, and directly test every code change that your developer, that you can develop that locally in for example, Kale MDK. You can develop that inside of the cloud, inside of a code space, and just push that to the code repository, what you're likely already doing today. And then have GitHub Actions react to that immediately come in and just look at that small change that you've just created, pick that up, put it into this virtualized ARM environment, compile it, execute it on this virtualized chip, and report back the test results directly into GitHub. So while you're inside of a pull request, you immediately get the feedback if what you just wrote, if the code that you just wrote actually does what it should and still conforms to all the requirements that you've set previously while defining the CI tests. And in the meantime, while this is running in the background, you really can go right back into your Kale MDK and can continue developing, right? You don't really have to always keep in mind that, oh, okay, I kicked off the test run right now, and I must go back there and click refresh a whole lot of times. No, it's just all inside of these GitHub Actions and completely integrated into the GitHub platform. What we also think is interesting about the GitHub Actions platform is that it has a couple of additional benefits that you might not have in your previous environment, that might be even hand-tailored or custom created for the workflows that you're executing today. So in GitHub Actions, I've just put a couple of the concepts where I think we have the most, the most innovation there. In GitHub Actions, we really believe in automating not just CI/CD, but since you're already living inside of GitHub as a developer and you're seeing the issues, for example, you're using projects, you're using discussions to discuss with your colleagues what you want to do. We've built actions to be integrated in all parts of this platform. So you really can completely react to any event, to any comment on an issue, to any new project item, and just pick that up and execute a pipeline based on that. So, for example, you could have the ability to have your pull request that tested your embedded workflow, and now you want to say, okay, it works in the virtual hardware. But in reality, I might have some wires attached to a device, and I want to actually see how it behaves in reality. I could just write a little automation that automatically deploys it to a test device on my desk as soon as I set the label for the pull request deploy to reality. And then actions would come in, take the build result and put that onto your real device very easily without having to worry about that integrated into your platform. This is just, just an idea. Also, another thing that Clay also mentioned is the scale aspect. So since GitHub Actions is running in the cloud and we're managing them for you, you don't ever have to worry if the embedded workflow that you're currently creating can be tested at the scale because you didn't buy enough chips or plug them into your compute cluster. You just run it and you just say, hey, I want to execute this, I don't know, 50 times in parallel. No problem. GitHub Actions can take care of that and scales to your needs. And if you only want to test it on one runner, of course, that's also possible. And another thing Clay mentioned before is that we have a new cultural approach to reusing parts, right? Open source and also inner source have the core principle of don't repeat yourself at their heart, right? You write a perfect logger library. Why would anyone else have to reinvent the logger for their project? You can just refer to that part and reuse it as a building brick inside of your entire chain. And with GitHub Actions, we've sort of taken this approach and also brought it to an automation platform. So we do have the marketplace. This is what we mean by enable exchange down here. We do have an actions marketplace that contains thousands of actions, which basically are semantic blocks, little semantic blocks that you can just put together with inputs and outputs that are well defined, and then spare yourself the effort of, for example, having to rewrite an entire script that will just do something that you can reuse from the marketplace. So this is stuff where we think this also changes a bit the way that you go and approach your CI and CD testing workflows. But this is all a bit abstract, maybe. Let's quickly look at a little demo that we have prepared here and see what this ARM and Actions partnership actually looks like in practice for you as a developer. So we have a little video here because Max managed to kill the live demo last night. And let's dive right in. So this is basically a repository where we have stored a program, an embedded program that does keyword detection, right? It uses an ML functionality to detect keywords. And inside of this repo, we've placed a generic GitHub Actions workflow. So this is just defined in YAML format, and it just executes very plainly some script steps that first set up our tool chain and build the application, run the application, and test the application results. So very straightforward CI/CD workflow, right? Not even the CD part, more the CI part. We're just testing and building it here. Now let's actually have a look at how GitHub Actions can come in and directly test changes that we introduce into the code. So we're just going into the program here and adding a small little change. Of course, in production, this would be something more useful. Here, we're just adding a little log message to show you that, hey, this line is actually being executed in a well-visible manner. And using the default GitHub workflow, we're creating now a feature branch and creating a pull request for this feature branch to introduce the changes we've just had into the main productive branch. And you can see right here, GitHub Actions directly jumps in as a check for this pull request and directly executes all of this build and test steps inside of a GitHub Actions Cloud Runner. So this is all running right now in GitHub Actions in the cloud. You can see we're having ARM Clang on here. The license is managed for us. We don't have to care about that at all. You can see here, we're now executing the program. We're running that also like on this virtual ARM hardware. You can see the change we introduced that happened in the log. So it's really the program where we've just committed the small little change being executed directly on a virtual chip, now being tested all in the cloud, not having to worry about anything but writing the code. And another nice thing is due to the integration in GitHub, you can directly see the result of the checks and have that also as a sort of quality gate before you can introduce any changes into your production environment, right? So also very, very nice stuff that we have inside of GitHub Actions there. Now, that was a very quick demo, I'm aware, but it really showcases, this is not not rocket science to use. For you as a developer, it's very approachable, very easy. You just write the code you usually would, but you can forego all of the associated pain with building and testing the application in other environments. So the benefits that we see, the main benefits here that are very clear: no setup and no setup problems, no cost of calculating before, if you're doing this at enterprise scale, how many chips will I have to buy, right? No worries about how many licenses for my test execution and build agents do I have to buy beforehand. You just go ahead and start using it. It's built by minute, so you don't really have to have a dedicated license per runner. You can scale it up to how much you need and keep the cost as low as you want it. And in the end, it's also very cool to be able to exchange that with the community. And that's sort of what I'm also very excited about, is when we're rolling this out and making this wider available, right? GitHub has this huge open source platform. And today, if you look into the GitHub marketplace, I mean, there is also embedded libraries, of course, that are being exchanged on GitHub. But today, when you compare it to other open source projects, there's not the same amount of testing going on. It's not as collaborative. There's not the same amount of exchange possible for CI and CD projects, because if you have a pull request against an embedded project on GitHub.com, it's not as easy to test these changes for the maintainers. And if we roll this out to the global community in the future, then I believe this will really fundamentally have the option to make it much more accessible to develop for embedded systems, and also revolutionize a bit the exchange of ideas and concepts and community interaction in this entire space. So this is also something that I'm super excited about. And if you want to get started with this, just send emails to Clay, and send a lot of emails.
Yeah, we are still in the beta, and we're hoping to get out of the beta pretty quickly, but we will be at Embedded World also with some more hands-on demos. But we've got a few questions that are popping up here around the pricing. The information basically runs on top of the current GitHub Actions infrastructure and pricing models, which are based on how many cores and how much concurrency you want. I dropped a link out in the Q&A there. But yeah, if you have questions about getting signed up and getting access to the beta, feel free to shoot me an email. We'll get you turned on as soon as we can.
Amazing. Thank you both so much. Let's just click onto the next slide. I think, yes, that is the one. Thank you. No worries. No, definitely do sign up for the beta. Clay, I'm gonna ask a bit more. Go on. Is there anything more you can share about timelines on the beta and when we're going to be out of it? Everyone goes, oh, it's in beta. This is great. I'm going to try it out. But when's it going to come out of it? Have you got any more timelines on that?
We're looking at our target is like the middle of this year, so during summer is what we're targeting. Our product team, like everybody else, is like, shh, don't commit to dates. I'm in sales, of course. It's about then. But the beta is running on top of the production actions infrastructure. We're just working through, we're definitely in a ship to learn mode here, as we talked about the value of Agile. To get feedback from the community, we're very hyper focused on ensuring that we deliver the best experience for developers, and so we want people using this stuff for out in the wild. I know the virtual hardware platform itself is very mature, but we want to see how that operates inside of the GitHub Actions infrastructure at scale. And we have teams that are using it now, and we're just looking to get some more customer and prospect type participation.
Awesome. So it's coming soon, not long now, not long.
Exactly.
So awesome. And if you like, if folks on the call like what they've seen today and want to get a bit more insight into this demo, this integration, the fantastic work from the teams at ARM and GitHub, Then we've got ARM has a presence at Embedded World, which is coming up in a month's time, pretty much almost exactly a month. It's crazy how time flies. March 14th, 16th. So do come and join us there. Hall 4 stand 4504. We've got a variety of demos on our booth, one of which is from here, from the folks at GitHub. So do make sure you come along and chat with the guys there and find out more about this incredible integration and the opportunities you have in your workflow to start trying this out, start using it, and to get involved in the beta. And yes, I think, Clay, although it's 8:30 in the morning, your inbox might be swamped with emails before this talk is done. So I don't know how you feel about that starting the day with a few hundred emails in there, but do email Clay and ask for any further details on getting access. So, and I have to say, in terms of audio setup, Clay, just phenomenal. It's like he's got the best audio setup of any presenter. No digs to any prior presenters. We love all of our presenters equally, but your audio setup has to be one of the best. It feels like I'm on the radio or on TV doing some kind of voiceover work with you.
This was a COVID hobby. It was I've picked up audio engineering, and my karaoke obsession continues.
Absolutely. I thought you were going to give us a little sing song at the end of this. So
it's still early.
It's still too.
I didn't have any of those. I didn't have any of those spirits like Max had in his big glass.
I know. If folks on the call, if anyone on the call wants to see Max's water glass here, that is definitely water in that.
You don't have to refill as often.
Exactly right.
True.
It's fab. It's fantastic. Well, as we've been chatting away, lots of questions have come in, and I know that folks on the call and indeed from ARM as well as GitHub have been answering them. So do keep your questions coming in. I'm just going to recap a couple. There's been some really great questions that have come in. I'm just going to highlight a couple. Head to the Q&A box for more info on that. There was a question around, which I'll quickly just paraphrase the answer on, around AVH simulating interactions with other embedded components. There are various virtual interfaces available. Reinhard's put a link in the reply to that Q&A, that question, sorry, in the Q&A box regarding those interfaces, and in particular has highlighted the virtual streaming interface, the VSI. So do check that out if you're interested in that in particular. There's one here, we've already talked about the cost structure as well, and the code spaces, and regarding target debugging possible with code spaces. As well. I don't know if you've got anything further to add to that, Clay, but Reinhard kind of answered on that question. Is target debugging possible with code spaces? And said, well, with Carl Studio Cloud.
Yeah.
So exactly. So Carl Studio Cloud to claim in. So unless there's anything further to add on that, I'm happy to jump over to the other questions we've got to answer already. And yes, sorry, just to reply to a question we just had come in that Reinhard's also answered. Yes, there's a link there regarding the support of the ARM chipsets and how all Cortex-M processors pretty much are covered there. So I'll mark that as done. Let's have a look at some of the other questions coming in. How straightforward would it be to link up GitHub Actions with a physical test device, as in the scenario described by the presenter?
So that's actually something, well, I've not tried out this exact use case, but maybe if you've seen the last Summerfest presentation from GitHub, that's actually where I took a Raspberry Pi, so also a platform that's pretty close to the hardware, and put a GitHub Actions running environment on there. So we do have an ARM runtime for GitHub Actions that you can just register as a runner, for example, and that you could use to also physically run GitHub Actions on device, or even deploy from one device to another that might be linked up via SPI or something like this. So it should definitely be possible.
Definitely. And actually talking about GitHub Actions, right? I mean, you were talking about the community, excuse me, in GitHub Actions being quite big. Do you know how many actions are actually on there are on the marketplace?
So I think it's currently more than 17,000. But wow. I remember when I joined, it was actually less than 10,000. So this is really blowing up. In a good way. Yes, exactly.
Yes, popularity is good. So that's good. And I think we've covered this but just to reiterate, maybe there's been a question around: are there costs associated with requesting a beta version to use?
They're not. So the initial beta access, we're probably a pretty small group, and then we'll have a broader public beta coming not long after Embedded World. With the way GitHub Actions platform works, individual developers have and enterprises with a enterprise account have a preset number of minutes that are already allocated that are free with your account, and then you use those to burn down. And so these will be during the beta period, just like those. So if you want to use really test this thing out and you wanted to run it on some larger runners, you're going to burn through more minutes faster. But there's the charge is based on the consumption. Now, after we get through the beta period, and again, this is why we're working together to figure this out. The intent, of course, is to build the licensing cost into the per minute charge so that you don't have to go procure separate licenses. You just fire up an action, you manage it the same way you manage the rest of your compute infrastructure.
Fab. Thank you, Clay.
Mm-hmm.
And then I think this kind of relates slightly to, if I understand it, the question correctly, to Reinhard's answer, but we can ask this as well to you folks if you've got anything to add on. Can we test some input outputs in the simulation environment or sensors interfacing?
Yes, this is definitely possible. The exact extent where, which specifications your sensor maximally to a maximum can have, that is something I would have to double check, but you can definitely add some virtual components there.
Amazing. Thank you, Max. And yeah, do keep your questions coming. We've got a few more minutes for questions, so do keep them coming in. And as we said, if you want to catch up with any of our tech talks and watch any of the past tech talks, they're all on youtube.com/arm. To answer a question I've just seen in the chat that's come into me, slides will be available as soon as possible after today's talk. So keep an eye out for those. That'll be in the follow-up email you receive in a couple of days' time, if you would need a reminder for that. And all our upcoming talks are on arm.com/tech talks. So that's covered a couple of little just housekeeping questions. So we'll just give it another moment if anyone's got any final questions from the audience. I guess, Clay, and Max, while we're waiting for that, is there anything in particular you wanted to kind of delve into a bit more, or highlight, or talk about a bit more in this presentation? Is there anything else you wanted to mention based after some of the questions we've got, or anything else you'd like to geek out on or nerd out on, or talk about a bit more with regards to your fantastic work that you've been working on with ARM?
Yeah, what I'm really, really curious to see is, as I said, like what really motivates me to see is how this will impact also the community. Like as soon as this comes out of beta, this becomes available to the 100 million developers on github.com. Like how will this really drive innovation in the embedded space at the speed that we just have not been able to see before, right? I mean, especially when I see I, for example, am a big home automation fan. So there's this open source project called Home Assistant, and I'm sure some people here will know this. But if you look into the pull requests of that project, like many people come together to suggest changes, like with many other open source projects also. But if you receive this amount of input from the community, you need a way to reliably test this. And this is sort of where I see what we presented today as being the game changer, right? As being able to integrate that, just slap that onto your open source project pipelines and be able to just test whatever the community has suggested to you very quickly to see if it's still lets the program run. So that's definitely something that I personally am really excited to see, where in 1 year's time, for example, we will stand and how this will have its first impacts on this global community of embedded development.
Yeah, we did get a few more questions coming in, but I'm also really interested in understanding, the current workflow. How many people are currently adopting or feel like they really are doing continuous integration in their environment? What's working, what's not? Can you imagine or how virtualization and moving in the cloud could work for you? How many times a day are you doing builds, and how long do those builds typically take? Those are kind of things that I think I'd love to start to get out of the community. And if you emailing asking access the beta, I'll probably ask you some of those questions too, because as we're looking to kind of help craft and fine tune the offering, and share that information back with our engineering team in the spirit of true iterative feedback.
Exactly. Brilliant. Thank you both so much. And yeah, we've got a few questions coming in. I know Reinhard's covering a couple of those with regards to some of the communication protocols and the virtual streaming interface. So I'll let him just type a couple of answers to those. With regards to the simulation, he's great at answering these.
Yes, he is, isn't he?
So simulation does it cover only the functional behavior or timing related performance also? If that's related to the ARM virtual hardware component, it is focused primarily on a functional model of the silicon. So that's really what we're focusing on here, functional software development test. Can a matter fabric be created with AVH? If I understand that correctly, if they're referring to matter, the standard, or if they're referring to something else, but if we're talking about the matter standard, then yes, I will refer you to the prior 2 tech talks we did on matter with ARM virtual hardware. In fact, no, sorry, the last tech talk we did on ARM virtual hardware with Canonical. So do check that out. That's on youtube.com/ARM. It will come up as one of the most recent videos we did with Canonical. And I think, just while Reinhardt's answering those questions, and I'll let him finish off, I think that is everything we've got time for today. So Clay, Max, do you have anything else to wrap up with today before we close?
Just if you're going to be in embedded world, please do stop by. We'll have a booth there, and we'll also be at the ARM booth, and actually we'll be at the Microsoft booth as well. So come by and get some swag. Hopefully we'll have some good stuff.
Wonderful. Yeah, thank you for having us. It was great to be able to share this vision with an audience.
Absolutely. No, thank you both so much. Yeah, no, I'm looking forward to meeting folks in Embedded World too. I'll be there, so look forward to some of that GitHub swag as well, and to seeing some of the great demos and work you're doing with ARM. So thank you both, Clay, Max, for a fantastic presentation and a great opportunity for our audience to see how they could use it. Audience, get involved with the beta. They want your feedback. They'd love to hear from you. We'd love to hear from you as well about how you're using ARM virtual hardware. So do check it out and work with GitHub and work with us on that. So we're really excited about it. If you want to catch us next week, same time next week, we'll be hearing from 56K Cloud. So do check out that tech talk. That's on arm.com/tech talks to register. And we'll see you the same time again next week for that. In the meantime, hope you have a great rest of your Tuesday. And Clay and Max, thank you ever so much again for a great presentation today.
Thanks, Tobias. Appreciate the invite. Thanks, Reinhardt.